All right, to continue with chapter 7.1, we got conditional statements now. And we can think about these statements as if P, then Q. And we can use the little mathematical symbols that we say P, right arrow, Q. That is implying if P, then Q, or you can think about it as P implies Q. So once again, we are going to construct a truth table as it relates to conditional statements. So we're going to we got P, we have Q, we have our conditional proposition P implies Q. And then once again, we're going to just fill out our truth table. All right, so if both of our inputs, P and Q, are both true, then the conditional statement P implies Q is going to be true as well. Now, if P is true but Q is false, then the conditional statement P implies Q is going to be false. And then lastly, if our P or our if statement is false, then we are going to say that our conditional statement as a whole is vacuously true. So it's kind of a little bit of an unexciting result. But as long as our inputs of a conditional statement is false, then we know the conditional statement as a whole is going to be true. All right, so we have discussed conditional statements, conjunctions, and disjunctions. To continue on this, we can talk about, we know what a proposition is. A proposition is simply a statement. So proposition P, a negation is simply saying the opposite, so not P. So this is just saying not P. So if P was a statement, 2 is an even number, the negation of P would be P is not an even number. And once again, a negation of a statement is going to have either a true or a false statement applied to it. Now, if P is true, then the negation of P is going to be false. And if P was false, then the negation of P is going to be true. All right. Some more things. So if we have the converse of P implies Q is Q implies P. So we're just flipping the P and Q when we talk about a converse, and then the counterpositive of P implies Q is not Q implies not P. All right.